Hello and welcome. We have seen in previous lessons that the origin of artificial intelligence is the human being's desire to compensate for the uncertainty of the future by mathematical means such as probabilities. These means, which begin with data acquisition and analysis, are based on the concepts of correlation and regression, convergence to predictive modeling, the result of which is the probability of occurrence of an event. This knowledge is a small window open into the future, which allows us to make the best possible educated decision. There is, however, still a step to be taken between knowledge of probability and decision. It is often dependent on a threshold that varies according to individuals. For example, someone will take an umbrella with a 50% chance of rain when someone else does so only with 70 or 80% probability. However, if the rules that link the decision to probabilities are known, then they can be automated. In this case, we removed humans from the entire process, from data collection to decision making and execution. We can therefore really talk about artificial intelligence. We were asking at the beginning of this course, what would be the definition of artificial intelligence? Following are a few of them, and I recommend that of Russell and Norvig from their book Artificial Intelligence, A Modern Approach. It is a voluminous and very technical book, but it is the reference in this matter. Artificial intelligence, which is a complex subject by essence, is the convergence of several fields. Mathematics first, which, as we have seen, is the true foundation of artificial intelligence. Indeed, AI is based on predictive modeling, which is a mathematical calculation of probabilities. Economics then, because it is an area of application of artificial intelligence, as we always look for a form of optimization. Then, logically, we find neuroscience and psychology. As we have seen, artificial intelligence is based on the cognitive principles of choice and decision making, and the whole field of neural networks tries to reproduce the way the human brain works. When we talk about choice and decision making, we are necessarily talking about philosophy, which has introduced moral and ethical dimensions that we will talk about later. Computer science and cybernetics are the means of calculation, implementation, and execution. And finally, linguistics, because we must communicate with the machine that helps us make our decisions. Whether it is a code language or speech recognition or manual writing, communication remains essential. Let's now see a brief history of artificial intelligence. It is not new. Indeed, in Greek mythology, we find the reference to the giant Talos, a metal replica in bronze of a human being forged by the god Hephaestus. He goes 3 times a day around the island of Crete in order to protect the goddess Europe, who is living there. Between the 3rd and the 1st century before Christ, we find traces of an engineering school in Alexandria that designed steam automatons. The Middle Age saw the creation of several famous automatons, including a lion created by Leonardo da Vinci in 1515. In 1738, Jacques de Vaucanson creates a very famous artificial duck. Research on the mathematical formulation of thought and the fundamental principle of reasoning led to Boolean algebra in 1854. In 1950, Alan Turing wondered if a machine could think and design the test that bears his name. In the 1950s, Isaac Asimov wrote the novel The Robots and shared his vision of a future where humans and robots coexist. He writes the 3 laws of robotics that we will see later at the end of this course. In 1956, Arthur Samuel wrote the first computer program able to play checkers, and John McCarthy used the term artificial intelligence for the first time. Between 1980 and the years 2000, despite much progress in the field of machine learning, we witness a decline in interest in neural networks. This period is of approximately 20 years is known as the winter of artificial intelligence. In 1997, Deep Blue defeats Kasparov in the game of chess. But it was not until 2010 that neural networks imposed their superiority. In 2011, Watson annihilates humans at the game of Jeopardy. In 2015, AlphaGo beats the world champion of Go. And in 2016, the machine is officially more effective than a human being in the recognition of images, writing, and languages. Why such rapid progress in the recent decades? The origin of this must be found first in the considerable mathematical progress made in the field of machine learning. Then the sharing of programs and data in open source allowed a spectacular revolution. To this must be added the technological advance of connected objects, the Internet of Things, being a phenomenal source of data to analyze. And finally, the technological evolution of computers, polarized under the name of big data, has offered the necessary storage and computational capabilities for this evolution. We have defined 2 levels of artificial intelligence. The weak artificial intelligence, the one that acts and executes like a human being. This one focuses on the near-perfect execution of a single task. This is the artificial intelligence we know today, the one that plays chess or drives a car. And we have the strong artificial intelligence, the one that thinks like a human being. This one is currently reserved for the field of science fiction. There is no sign today that it will ever be, so much complex is the human brain. All this theory we've just been going through on artificial intelligence has to be implemented and executed at some point. The implementation will be done through intelligent agents. An intelligent agent is a hardware entity that concentrates all the functions of artificial intelligence. It will record data, analyze it, submit it to a predictive model, and according to the knowledge obtained, make a decision and execute it autonomously. Intelligent agents are defined through a model called PEAS, P-E-A-S, for performance, environment, actors, and sensors. Here we see an example of an intelligent agent, which is the small autonomous vacuum cleaner Roomba. In the case of Roomba, performance is measured in terms of cleanliness and efficiency. The mathematical cost function will tend to optimize the cleaning for a minimum energy consumption. The environment of Roomba is the set of rooms where it will evolve, with their furniture, their floor, and their static or mobile obstacles. The actors are the wheels, the brushes, and the vacuum cleaner. Sensors, which are the means of acquiring data, are multiple and sophisticated. It is equipped with cameras, dust detector, declivity detectors in order to avoid falling downstairs, asperities detectors for carpets, and infrared sensors for the walls. Roomba is a perfect example of everything we've seen so far. The willingness to assist human beings in repetitive or complex tasks with the ability to make decisions and execute them independently. What we should remember is that artificial intelligence has a long story. It is the result of the execution of a decision following a calculation of probabilities. It is the convergence of several disciplines, mainly mathematics, computer science, and cybernetics. And it is implemented by means of intelligent agents. That's it. Now you know what artificial intelligence is, where it comes from, and how it works. In the next course, we will see several examples of its applications. See you soon.